Now our topic for today is machine. So we are going to divide the topic under machine into two. One will base on type of machine and level, which is classes. Right? The second will base on velocity ratio of machine. Now for today's own, we say machine. And what is a machine? A machine is a tools or device which allow force called effort applied at one end to overcome resistive force called load applied at other end. Which means a machine must have three major parts. Where you are going to apply your effort, the way you are going to place the load, then the movable part of it called pivot or fulcrum. Now we have 7 major types of machine. So we have lever, we have inclined plane, we have wedge, we have screw jack, we have pulley system, we have gear, we have wheel and axle. Now we have 3 major parts of machine, like I said. We have effort, we have pivot, we have load. Now let's go to lever. When we say lever, lever has classes because of the arrangement of those 3 parts. We have first class lever, we have second class lever, then we have third class lever. Then how will you identify them? For the first class lever, is the arrangement of those 3 parts you need to take note. Moment you discover that a machine or a lever has the pivot at the center, like the scissors. Look at this. We have, this is where we are going to apply our effort. Then this is where we are going to place our load. Then the movable part of it is here, which is called pivot. So in that case, we call it first class lever. So which means when you have the arrangement of the 3 parts, like we have effort, pivot, load. The moment the pivot is at the center of any lever, we call it first class lever. But if we have it such that we have load at the center, that is effort, load, then what? Pivot, at the moving part of it, or it may be pivot, load, and what? Effort. The major thing is which one is at the center. Moment the load is at the center, we call it second class lever. And typical example of that is our wheelbarrow. If you look at it, see that the load will be at the center, we apply our effort at the back, then the movable part of it is in the front. So once the load is at the center, we call it second class lever. Then the third class lever is when we have effort at the center. When we have effort at the center, and we classify short lever as third class lever. It may be load, effort, and pivot, or we have pivot, effort, then load. So the major thing is the effort must be at the center. If you look at this type of stapler, we hold it like this. So this is where we are going to apply our effort. Effort is at the center. Then the load will be here. That is the pin and the paper we want to staple. Then the movable part of it is at the back here. Therefore we have pivot, effort, load. Once the effort is at the center, we classify it under third class lever. Third class lever. So those are the 3 classes of lever with the example. Now let's go to mechanical advantage of machine. Any machine, any type of machine, they have the same formula for their mechanical advantage. Mechanical advantage of any machine is the ratio of load to effort. Therefore, mechanical advantage is equal to load over effort. So it has no unit because the load must be in Newton, while the effort also in Newton. It will cancel each other, so it has no unit. Now the next one is velocity ratio of any machine. Is the ratio of distance moved by the effort. Just change this one, bring this one up and bring this one down. Let effort go up, this one will come down, but her distance, not exact load. So it's the ratio of distance moved by the effort distance moved by the effort over distance moved by the load. So since this one is distance, which is in meter, this one too is in distance, which is also in meter. So it means velocity ratio also has no unit. Now the next one is efficiency of machine. Efficiency of machine. Efficiency of machine is the ratio of work output to work input. Therefore, we have efficiency of machine is equal to work output over work input multiplied by 100 over 1, because efficiency is always in percentage. Now this is not only formula for efficiency. Efficiency has this also as formula, that is mechanical advantage over velocity ratio multiplied by 100 over 1. And if we look at it, it means if this is efficiency, this one is also efficiency. It means this one equal to this. So work output over work input is equal to mechanical advantage over velocity ratio. It's another question on its own. They may ask you to prove that efficiency of machine is equal to this. So you are going to start from this one. Then what is work output? That is the what? Force, that is the load, multiplied by distance moved by the load. So it will be what? Load multiplied by distance moved by the load. Then what is work input? The effort supplied to the machine. That is effort multiplied by distance moved by the effort times 100 over 1. So we can easily write it like this as load over effort multiplied by distance moved by the load over distance moved by the effort times 100 over 1. Then what we need here to get velocity ratio is just to look for reciprocal of this. Therefore, we can write this as load over effort multiplied by 1 over distance moved by the effort over distance moved by the load. And this one will give us velocity ratio. Therefore, efficiency of machine is equal to, this is mechanical advantage multiplied by 1 over velocity ratio. Don't forget to multiply by 100. So multiply by 100 over 1. So this will give us mechanical advantage over velocity ratio times 100 over 1. Then I want you to take note of two things before the end of the class. The first one is the use of this 100. If your percentage is given, let's say you are given 40% now, and want to make use of it. The moment you write 40 over 100, this 100 represents this one. So what you just need to write is mechanical advantage over velocity ratio. Don't write multiply by 100 again. Or you can just write only 40 here, then this one will be multiplied by 100. Then lastly, the another question is, why is it that efficiency of machine is always less than 100%? Yes, because of the frictional force in the movable part of machine. It generates heat, and it's the part of energy that we are supplying, part of the force we are supplying to the machine, that is changing toward heat energy or sound energy. So at the end of the day, you discover that efficiency of machine cannot give you 100% again.